That was the harder stuff yesterday. This is the easier stuff, so that's good news. Our new notes today are on what we're calling composite functions. So we have our composite functions, and a composite function is where we take like one function and put it inside of another function. So we're going to take one number and then we're just going to plug it in. For those of you who like numbers and like mathy stuff, this is going to be a piece of cake. For those of you who don't, just hold on, because it's not very difficult. It just looks tricky. So what we're going to do for each of our composite functions is start with at least two functions. So you're going to have one function that they're going to just call something of x. In this case, we call it f of x. And a second function we're going to call something else of x. So they have to be two different letters, otherwise we'd think it was the same function. So f and g don't mean anything. It's just the letter they picked to go there. So we have f of x is this function, 3/4 times x minus 3. And g of x then is this function, the absolute value of x. Remember, for absolute values, whatever number we put in, when we pull it back out of the absolute value sign, it's positive, right? Absolute values, get rid of that. So they're going to give you problems that look like this. G of f of x, which looks cool. I love algebra 2 because it always looks like we're so smart. All we have to do for g of f of x is start with the x in the middle. We're going to take whatever value they give us for x, because we started the insidemost parenthesis, and we're going to take that value and we're going to plug it into the f equation. And we're going to get the answer. So to plug something in, whatever value they give us here for x, we're just going to find the f equation and plug it in. So whatever that number is, we'd replace x in this equation for that number, and then we'll solve. Then we're going to take this answer, whatever we get when we plug it in and solve, and we're going to put that in to the g equation. So we're putting the whole f in for the g equation. Some people like to write the whole thing out. Like, I've seen people who take this f equation then and stick it inside this g equation. Sometimes that works really nicely for those of you who are really into numbers, but sometimes that's a little tricky. So I usually just stick with plug it in, find my answer, then plug it into the next one. And that makes my life a little more simplified. So, to find g of f of x, we could take that whole equation and plug it in, like I just said, to the absolute value sign. We take this one, we plug it into there. Or you could do it in pieces. So this was just kind of a couple examples. I'm going to slide this up in a second so you can write down an example with numbers. So I don't want to stress anybody out, but we are going to move along here just so you can kind of get the idea. So all we do is take this answer and plug it into the other equation. Yes, ma'am.
So those parentheses around the x and the 3, those have to be there?
Yes.
Because it was in the original equation.
Right.
Up top, okay.
Because it was here, we put them in down there.
Now, is that x and the absolute value, like, just there as a symbol, or is that supposed to be in there too?
No, I take that out and replace it with this whole thing. Okay? So it'll be easier to see down here when we look at a couple of examples. So here are 3 equations. Remember I told you there'd be at least 2. Well, this is a good example with 3. And we're going to do a couple different things with it. And this is the one, if you're going to write down notes, I'd say you should write down. So we have f of x equals negative 2x plus 7. We have a second equation, a g of x equation, equals x squared minus 2. And finally, we have an h of x equation, which is x plus 1 squared. So, in our first example, we'll try to just limit our confusion here. They say, find f of 4. So what this tells us is we're using the f equation, and every place there's an x in the equation part, we're going to plug in a 4. We don't plug the 4 in on this side, and some people get confused by that and then try to solve. It's not what we're doing here. They're not saying the f of x equals something. They're just saying, what's f of 4? So we're going to take that 4 and we're going to plug it in for each of the x's in our f equation. So our f equation is negative 2x plus 7. I just copied that down from up here. And then every place there's an x, I'm going to replace it with 4. So now instead of x here, I'm going to put in 4. So I have negative 2 times 4, which is negative 8, plus 7. Negative 8 plus 7 gives me just negative 1. So the first way we're going to use those composite functions is simply to plug the numbers in. Questions about that part? Alright, then sometimes they're going to give them to us in bunches. So like the first example we looked at, we're looking for f of g of 3. So we always go all the way to the insidemost parenthesis. The number that we're plugging in is 3. And we're going to plug that in first to the g equation. So I find my g equation, x squared minus 2. And I'm going to copy that on down here, x squared minus 2. So I have g of x equals x squared minus 2. Every place there's an x, I'm going to plug in a 3. So that's going to change that equation to be 3 squared minus 2. And even though this is here, it doesn't mean anything. It's not an actual 3. It's g of 3 or g of x. So 3 squared is 9. Minus 2 is 7. Now, we've taken care of this part. We found g of 3 was 7. We're going to take that 7 then and plug that in to the f equation. So, we need to write down our f equation, negative 2x plus 7. And every place there's an x, now we're going to plug in the 7 that we just got. So we take negative 2 times 7 plus 7 to get negative 14 plus 7. And negative 14 plus 7 gives us negative 7, or our final answer. So we took our value, we plugged it into the g equation first, and then we took that whole answer and plugged that answer into our f equation. Questions about that? Alright. The last two, like letter C, I just want you to look at for a second. You don't have to write it down. But sometimes they just put a variable here. So instead of an x, they put an a there. We still are going to do the same thing. We're going to take the a and plug it into the g equation. So everywhere there's an x, we're going to put an a. It doesn't really help us a ton, but we might use it for something later. So we have a squared minus 2 when we take the a and plug it in. Then we're going to take that whole thing, a squared minus 2, and go up here to our f equation, because now we're back out to the f side. And we're going to take a squared minus 2 and put that in for x, in our, up here, in our f equation. So we have the negative 2, just like the negative 2. Then instead of x, we're going to put in a squared minus 2. And then at the end, we still have our plus 7. Now, that particular one is not so helpful, but we could distribute. Negative 2 times a squared gives us negative 2a squared. Negative 2 times negative 2 gives us a positive 4. Plus 7, bring that down. So we have negative 2a squared plus 11. Is that super helpful? Not really. But later on down the road, they're going to ask us to put some things together like that so that we can come up with an answer later. And so they'll give you that. Once you find that, you'll be able to solve that against something else. But not in this chapter, so we're good. And our final example, and we're just going to try to set it on here with our equation so you can follow along. Just uses that h equation. So they say find g of h of negative 2. So we start again all the way in the middle with the negative 2. And we're going to plug that into our h equation this time. So our h equation is x plus 1 squared. So everywhere there's an x, we're going to put in a negative 2. Negative 2 plus 1 squared. Negative 2 plus 1 is negative 1, which when I square it gives me positive 1. Now I'm going to take that positive 1, so that's what this whole thing equals, and I'm going to plug it into my g equation, which was x squared minus 2. So I'm going to take that positive 1 and plug it in here for the x. 1 squared minus 2 gives me 1 minus 2, or just negative 1 for my final answer. Questions we have right now about composite functions? Yes, ma'am.
So these are all like, each thing that they give you is like a separate problem. It's not like all related back to one. They're just like different versions.
Yes.
Okay.
Yep. Other questions? Alright. Then, our assignment today is 2 parts. We're going to do some problems in the book on page 228. And a handout that has review for our test. So we will pass out the handout here in a minute. My other classes actually started this handout yesterday, so they're just going to finish that handout today. But you guys didn't get it yesterday, so you are going to start it today. And we can go ahead and get started.